सो हेलो एवरीवन। आज हम लोग ये एक शॉट में पूरा एल्कालॉइड ख़त्म करने वाले हैं। ओके, सो टुडे आर गोइंग टू कंप्लीट द एल्कालॉइड इन वन शॉट। Alkaloids in one shot only. So basically, what are alkaloids? So first of all, alkaloids are basic in nature, having nitrogen in their structure. Okay, they are weakly basic. Why? Due to the presence of nitrogen. So alkaloids are basic in nature. Why basic in nature? Due to the presence of nitrogen in their structure. Okay, so alkaloids are basic in nature due to the presence of nitrogenous base in their structure. Due to the presence of nitrogen in their structure. So now we are going to study the different characteristics of alkaloids. Okay, different characteristics of alkaloid. First of all, they are derived from amino acid. It's very important. Derived from amino acid. Alkaloids are derived from amino acid. Alkaloids are derived from amino acid. If possible, make a short note. It will be very important. It will be very much beneficial for you because I will give all the important information, okay, about alkaloids. Yes, Mahfuz, good evening. So they are having significant pharmacological effect on animal bodies. Alkaloids are having significant pharmacological effect. Pharmacological effect on animal bodies. For example, ephedra and again physostigmides, they are having parasympathomimetic and parasympatholytics, these types of characters. Okay, so they are having pharmacological effect on human body because of the nitrogen. This is basic. Already I mentioned that because of the nitrogen, the alkaloids are basic in nature. Now let's start with the classification of alkaloids. What are the different classes of alkaloids? So classification of alkaloids. Alkaloids are basically classified into three types, that is true alkaloid, protoalkaloid and pseudoalkaloids. So true alkaloids, protoalkaloid and pseudoalkaloid. Okay, true alkaloid, protoalkaloid and pseudoalkaloid. Okay, so what are true alkaloids? True alkaloids are those in which nitrogen base is also present in their ring. Along with that, they are also derived from amino acid. Nitrogen is present in their ring. Along with that, they are derived from amino acid. They are also derived from amino acid. For example, tropane alkaloid. Tropane alkaloid has nitrogen in their structure. Along with that, they are derived from amino acid. Second is pseudoalkaloids, protoalkaloids. What are protoalkaloids? Protoalkaloids has nitrogen outside the ring. Along with that, they are derived from amino acid. So protoalkaloid has also nitrogen present, but in the ring. Here present in the ring, but in protoalkaloid, nitrogen present outside the ring. Along with that, they are derived from amino acid. Derived from amino acid. What are the examples? Example, you can take ephedra, colchicum and all these. Okay, example, ephedra, colchicum. Here the example is tropane alkaloid. Tropane alkaloid is an example of true alkaloid. Propanol colored is an example of true alkaloid, and ephedra colchicum are example of protoalkaloid. Next you will find pseudoalkaloids. These pseudoalkaloids, in this, nitrogen is present in the ring, by they are, this is pseudoalkaloids. In this what will happen, nitrogen will be present in the ring, but they are not derived from amino acid. So nitrogen is present in ring, but they are not derived from amino acid. Okay, so these are the three different classes of alkaloids. Number one is protoalkaloid, number one is true alkaloid, number two is protoalkaloid, and number three is pseudoalkaloid. So true alkaloid has nitrogen in their ring, protoalkaloid has also nitrogen but it is outside the ring, and pseudoalkaloid has nitrogen in their ring. Okay, the most important point here, what is the difference, that the true alkaloid is derived from amino acid, whereas protoalkaloid is derived from amino acid but the nitrogen is present outside the ring, and pseudoalkaloid is not derived from amino acid but it has nitrogen in their ring. Okay, now this pseudoalkaloid is again classified into three types. This pseudoalkaloid is again classified into three types. What are they? The pseudoalkaloids are subclass. They have subdivided into three types. That is steroidal pseudoalkaloids, terpenoid pseudoalkaloids, and xanthine pseudoalkaloids. So number one is steroidal pseudoalkaloids. Number two is terpenoidal pseudoalkaloids, and number three is xanthine pseudoalkaloids. Number three is xanthine pseudoalkaloids. Okay, so now we are going to start learn about the different subclasses of pseudoalkaloids. Example of steroidal pseudoalkaloids is veratrum. You can say veratrum. Example of terpenoidal pseudoalkaloids is aconite. And example of xanthine pseudoalkaloids is coffee tea. Okay, so these are the example of pseudoalkaloids. Can you please repeat after me? Once revise, please. So the alkaloids is classified into mainly three types. They are true alkaloid, protoalkaloid, and pseudoalkaloids. Out of that, true alkaloid has nitrogen present in their ring, and they are derived from amino acid. Example is tropine alkaloid. Next is protoalkaloid. Protoalkaloid has nitrogen, but it is present outside the ring, and it is also derived from amino acid. Whereas pseudoalkaloid has nitrogen present in the ring, but it is not derived from amino acid. Now, this pseudoalkaloid is again divided into three subtypes. There is steroidal alkaloid, terpenoidal alkaloid, and xanthine alkaloid. Steroidal alkaloid example is veratrum. Terpenoidal alkaloid example is aconite, and xanthine alkaloid example is coffee and tea. Xanthine alkaloid example is coffee and tea. Now we will see the different general properties and the characters of the alkaloids. What are the general properties and characters of alkaloid? Okay. In this first one is that alkaloid are normally have definite shape and size, and they are crystalline in nature. Okay. Number two, they are basic in nature because of the presence of the nitrogenous base. Number three, they are soluble and insoluble. We are going to learn that. Okay, so general properties of alkaloids. What are the general properties of alkaloids? Number one, majority of alkaloids are colorless and crystalline solids. Number one, majority of alkaloids are colorless and crystalline solid. Majority of alkaloids are colorless and crystalline solid. There are some exceptions. Okay, so we have to remember that exceptions. That's are most important. So the exception for colored alkaloid are, write in red pen. Wait. Exception. In this colored alkaloid, number one, berberine. Berberine is yellow. Number two, betadine. It is red color. And number 3, sanguinary. It is copper red. It is copper red in color. Okay. Next, what I mentioned that they are colorless, but these are the exceptions. Berberine is yellow color, betadine is red color, and sanguinary is copper red color. And again, I also mentioned that they are crystalline solid in nature, but some are amorphous in nature. Okay, so you have to remember what are amorphous in nature. Amorphous in nature, that is ametine. Ametine is amorphous in nature. Next, what I mentioned that these are solid, but exception for solid is liquid alkaloids. Some are liquid alkaloids. What are the exception for liquid alkaloids? Number 1, volatile. Volatile, nicotine, spartine, conine. Nicotine, spartine, and conine. Nicotine, spartine, and conine. Second, non-volatile. What are non-volatile? They are pilocarpine, D-pilocarpine, and hyoscine. So these are volatile in nature. So can you please repeat after me? So general properties of alkaloids. Number 1, alkaloid are colorless and crystalline. Alkaloid are colorless and crystalline solid. But example, some exceptions are there. This exception, first of all, berberine is colored, that is yellow in color. And then betadine is red in color. Then sanguinary is copper red in color. Next, what I mentioned that these are crystalline. But exception for amorphous are ametine. Ametine is amorphous. Ametine is amorphous. Next, what I mentioned that they are solid in nature, but exception is liquid alkaloid. These liquid alkaloid are two types, volatile and non-volatile. Volatile is nicotine, spartine, and conine. Volatile is nicotine, spartine, and conine, whereas non-volatile is pilocarpine, hyoscine, and D-pilocarpine. Pilocarpine, hyoscine, and D-pilocarpine. So you have to remember that. Okay, these are the exceptions. Number 2, majority of the alkaloids are optically active. Majority of the alkaloids are optically active and they are laboratory alkaloids are laboratory or biologically active. So number 2, majority are optically active. Majority are optically active. They are laboratory alkaloids are biologically active. Laboratory alkaloids are biologically active. So some exceptions are there. Optically inactive alkaloids. Now write exception. In this exception, first one is optically inactive alkaloid, piperine. Optically inactive alkaloid. Example is piperine. Optically inactive alkaloid, piperine, which is biologically optically inactive alkaloid piperine, which is biologically active and it is a smooth muscle relaxant. So its biologically active and it's smooth muscle relaxant. Smooth muscle relaxant. It's smooth muscle relaxant. Number 2, dextroform is biologically active. Exception for dextroform. Dextroform which is biologically active. So D-pilocarpine and D-tubaculine. D-pilocarpine and D-pilocarpine and D-tubaculine. D-pilocarpine and D-tubaculine both are biologically active, but in which form? In dextroform. They are biologically active in dextroform. Next, both levorotatory and dextroform are biologically active. Example is quinine. So quinine, two types. One is plus quinine, that is dextroquinine and levoquinine. Dextroquinine is antiarrhythmic, whereas levoquinine is antimalarial. Dextroquinine is antiarrhythmic, whereas levoquinine is antimalarial. So next point is both levo and dextrorotatory. Both levo and dextrorotatory. Example is quinine. Quinine dextrorotatory, quinine levorotatory. So dextrorotatory is antiarrhythmic and levorotatory is antimalarial. So dextrorotatory is antiarrhythmic and levorotatory is antimalarial. So you have to remember that. Okay. So what are the general properties of alkaloids? Number 1 is alkaloids. Majority of alkaloids are colorless, crystalline and solids in nature. Exception is berberine, betanide, betanidine and sanguinarine. In this, berberine is yellow color, betanidine is red color and sanguinarine is copper red color. Again, amorphous is amethine and liquid alkaloid is volatile and non-volatile. Volatile is nicotine and spartine and conine, whereas non-volatile are pilocarpine, D-pilocarpine and hyoscine. Next, second point is majority are optically active, levorotatory and alkaloids are biologically active. So majority are optically active and levorotatory alkaloids are biologically active. Some exceptions are there. Optically inactive alkaloid is papaverine. Optically inactive alkaloid is papaverine, which is biologically active and it's a smooth muscle relaxant. Okay. Next is dextroform is biologically active. Example is D-pilocarpine and D-tubaculine. Next, both dextro and levorotatory active. Example is quinine. Dextrorotatory quinine is antiarrhythmic, whereas levorotatory quinine is antimalarial. So you have to remember this. Dextroform of quinine is also known as quinidine. Okay. So this dextroform is also called quinidine. It is also called quinidine. Next, we are going to the next point. Racemic form of is biologically active. Next point is that racemic form is biologically active. So which racemic form is biologically active? maximum of the alkaloids which are in racemic form, they are biologically active. For example, first of all, what is racemic mixture or racemic form? Racemic mixture is the equimolar concentration. Racemic mixture is the equimolar concentration of both the levo and dextro rotatory is called racemic mixture. So racemic mixture is having same concentration of both levorotatory and dextrorotatory, both dextrorotatory and levorotatory. This is called racemic mixture. This is called racemic mixture. So indicated by plus minus, it is directly indicated like this also. Okay. Next example is hyoscyamine. Hyoscyamine is also called atropine, which is racemic form is hyoscyamine. Okay. So example of racemic form biologically active is hyoscyamine. Hyoscyamine. This hyoscyamine is also called atropine. And atropine physostigmine is the antidote for atropine or atropine toxicity. So physostigmine is used as the antidote for atropine toxicity. Just for your information, I told you. Okay. So next, most of the alkaloids gives either colors on precipitate with organic acid and heavy metal. For example, carboxylic acid are organic acids. Okay. So acetic acid and formic acid and lactic acid. Okay. Next, general chemical test for alkaloid. This is most important point. General chemical test for alkaloids, which is mostly asked in the competitive exam. General chemical test. General chemical test for alkaloid. General chemical test for alkaloids. There are mainly four chemical tests. They are Mayer's test, Hager's test, Wagner's test, and Dragendorf test. Okay. 4 different types of tests are Mayer's test. Number 1. Mayer's test. Number 2. Hager's test. Hager's test. Number 3. Wagner's test. Wagner's test. And number 4. Dragendorf test. Dragendorf test. Okay. In this Mayer's test, which reagent is used? Dragendorf test, which color is final? Which of the following is found as the final color of Dragendorf test? These type of questions are very, very important. So in Mayer test, what is the reagent used? That is potassium mercuric iodide. Potassium mercuric. Simply you remember Mayer's test start with M. Mercuric iodide also starts with M. So KHgI2. This is called potassium mercuric iodide. Potassium mercuric iodide. And when the sample is mixed with potassium mercuric iodide, which color is formed? White or creamy precipitate is formed. So this is most important. In this, he will in the question it is asked. So what is the reagent? Potassium mercuric iodide. And what is the final color? That is white or cream color. white or cream color, creamy precipitate. Next is Hagar's test. In Hagar's test, what is the reagent used? In Hagar's test, saturated picric acid solution is used as reagent. Saturated picric acid solution. Saturated picric acid solution is used. And what is the final color found? That is yellow precipitate. Yellow color is found. Yellow PPT. Yellow precipitate is found. Next, Wagner's test. In Wagner's test, what is the reagent used? The reagent is iodide along with potassium iodide. Iodide plus potassium iodide. Potassium iodide. Iodide plus potassium iodide. And what is the color found in the final? The final color is reddish brown precipitate. Final color is reddish brown precipitate. Reddish brown precipitate is found. Which color? Reddish brown precipitate color is found. Okay. Next, drag and drop test. In the drag and drop test, the reagent which is used is potassium bismuth iodide. In drag and drop test, potassium bismuth iodide is used as reagent. Potassium bismuth iodide is used as reagent. And what is the final color is found? The final color is reddish brown precipitate. The final color is reddish brown precipitate. Reddish brown precipitate. So these are the main important points about the chemical test for the alkaloids. For chemical test of the alkaloids, this is most important. And every year, most of the year, one question are coming from this 100%. So what are the different types of chemical test used for the detection of alkaloid? They are mainly 4 types: Mayer's test, Hager's test, Wagner's test, and drag and drop test. Mayer's test, Hager's test, Wagner's test, and drag and drop test. Out of this, in the Mayer's test, which reagent is used? That is potassium mercuric iodide. So Mayer's test starts with M. Potassium mercuric iodide also starts with M. So you have to remember MM. So Mayer's test is done with potassium mercuric iodide. Okay. Next point, Hager's test. In Hager's test, which reagent is used? Saturated picric acid solution. And what is the final color found in Mayer's test? That is white or creamy color. What is the final color found in the Hager's test? That is yellow precipitate. Okay. And what is the reagent? Saturated picric acid solution. Next, Wagner's test. In Wagner's test, what is used as reagent? That is iodide and potassium iodide. Iodide and potassium, very easy. I plus Ki. Iodide plus potassium iodide. Okay. And what is the final color found? Reddish brown precipitate. Reddish brown precipitate. Next, number 4 test is drag and drop test. In drag and drop test, what is the reagent used? Potassium bismuth iodide. What is the reagent used? Potassium bismuth iodide. And what is the final color found? That is reddish brown precipitate. Final color is reddish brown precipitates. Okay. Next, we are proceeding towards solubility. So these are all about different chemical test for the detection of alkaloids. Okay. Now we will proceed towards the solubility. So according to the polarity, like dissolves like, everybody knows. Non-polar will dissolve in non-polar, and polar will dissolve in polar. So polar compound dissolves in polar compound, but not in non-polar solvent. Whereas non-polar will dissolve in non-polar but not in polar. Okay. The same thing will be there. And according to pH, acidic compound dissolves in basic solvent. So alkaloid are soluble in organic solvent. Why? Because alkaloid in basic in nature. Okay. First of all, let's write properly. Next point is solubility. General characteristics. Point 3. Point 3 is solubility. Solubility of alkaloids. Okay. So first of all, we have to remember its universal, that like dissolves like dissolves like. This is one of the most important and universal sentence. According to the polarity now. So polar soluble compound dissolves in polar solvent, but non-polar not dissolved. So polar will plus polar dissolve. Next, non-polar plus non-polar dissolve. Next, polar plus non-polar. Next, non-polar, same thing. We should not repeat again, non-polar plus polar. Okay, so in this polar plus polar, it will dissolve. Non-polar plus non-polar, again it will dissolve. But polar plus non-polar, it will not dissolve. And if non-polar plus polar, same, it will not dissolve. So this is all about solubility according to polarity. Now we will see solubility according to pH. Solubility according to pH, that's also important. In this, acid plus acid, next strong acid, strong base. Strong acid, strong base. Next strong acid, weak base. Strong acid, weak base. Next weak acid, strong base. Weak acid, strong base. Next weak acid, weak base. Okay. So in that case, strong acid, strong base, it will not dissolve. Strong acid, acid not dissolve. Strong acid, strong base, it will dissolve. Again, strong acid, weak base, it will also dissolve. Weak acid, strong base, it will also dissolve. Weak acid, weak base, it will not dissolve. So when the nature are same, weak acid, weak base, it will not dissolve. Okay. Why? In the case of strong acid, weak base, or weak acid, strong base, or strong acid, strong base, that conjugate acid or conjugate base can form. But in the case of weak acid, weak base, formation of conjugate acid will not possible. It will not form, and it is not possible. Okay. So alkaloid are soluble in organic solvent in their free basic form, but alkaloid salts are soluble in polar solvent like water. You have to remember that. If you are listening the record, then please note it down. That alkaloid are soluble in organic solvent in their free basic form, but alkaloid salts are soluble in polar solvents like water. Okay. Next, some exceptions are there about the solubility. So what are the exceptions? Number one, ephedrine with exceptions. Ephedrine, colchicine, caffeine. ephedrine, colchicine, caffeine, pilocarpine, and codeine. Codeine. Though they are free bases, they are soluble in both organic solvent and water. Free bases. Still they are soluble in organic solvent and water. Water is polar solvent, it is polar in nature. Okay, so though it is this ephedrine, colchicine, caffeine, pilocarpine, codeine, they all are free bases, still they are soluble in organic solvent and water. Okay, next example, morphine, theophylline, morphine, theophylline, and lobeline. You can write that morphine, theophylline, and lobeline, or you can write narcan. They are free bases, they are not soluble in organic solvent, whereas lobeline, apoetropine, hydrochlorine, and hydrochloride, they are salts, they are soluble in both organic solvents and polar solvents like water. Okay, so you can write that. Next important point is that quinine monosulfate. Quinine monosulfate is not soluble in water. You have to remember that quinine monosulfate is not soluble in water. Okay, now stability. Majority of the alkaloid will decompose or degrade after 80 degrees Celsius. Some alkaloids like caffeine, strychnine will under sublimation upon heating. Okay. Next, basicity. Based upon the nitrogen, that is primary, secondary, tertiary, or quaternary. Primary nitrogen, for example, protoalkaloid. Protoalkaloid is an example of primary nitrogen. So based upon the nitrogen, let's write this. This is important. So next point is basicity. So what are the different types of alkaloid present in the alkaloids? Number one, primary, secondary, tertiary, and quaternary. Okay, primary nitrogen is present in norpinephrine. Okay, right there. Primary nitrogen, secondary nitrogen. It is present in norepinephrine, and it is also present in muscarine. Secondary is present in ephedrine and colchicine. Secondary nitrogen is present in ephedrine and colchicine. Tertiary nitrogen is present in tropane alkaloid. It is present in tropane alkaloid. And quaternary nitrogen is present in D-tubacurium. Okay, so already these are the previously asked question. It is already asked in the GPAT 2019. Already you will find that question. GPAT 2019, it is already asked about that primary, secondary, tertiary, and quaternary. So which nitrogen is present in which compound? Okay, so in primary nitrogen is present in muscarine, secondary nitrogen is present in ephedrine and colchicine, tertiary nitrogen is present in tropane and tropane alkaloids, tertiary nitrogen is present in tropane alkaloids, and quaternary nitrogen is present in D-tuberculine. That's most important. This one, quaternary nitrogen, it is important, very very important. It's blockbuster drug. So in D-tuberculine, which type of nitrogen is present? Quaternary nitrogen. Quaternary nitrogen is present in D-tuberculine. Okay, quaternary nitrogen is present in D-tuberculine. Now, occurrence. Where does the alkaloid found? Alkaloids are normally present from lower class to higher class. All plants alkaloids present. From lower class to higher class, in all class alkaloids are present. For example, gymnosperm, algae, etc. So in from lower class to higher class, how we can classify that? So from top to bottom, okay. Algae, bryophyte, pteridophyte, gymno, ngo. So from lower class to higher class, in all you can find alkaloids. Okay, so alkaloids are also present in animals. For example, muscopyridine is present in musk deer, which has a very sweet smell, and this musk is used in the formation or in the preparation of fragrance or scent, and that what it is called, fragrance, scent, and okay, write that. Musk deer. It's very famous, musk deer, because of the smell only, that fragrance only. Okay. Perfume. It is used in the preparation of perfume. Okay. Next one is castor fiber is also present. Which type of? Tocastoramine. You can remember very easily. Musk deer, muscopyridine. Castor fiber, castoramine. Next in frog, epibastine is also epibastidine. It is also found in frog. So what does it means? It means that alkaloids are found in plant as well as in animal. In plant it is found from lower class, that is algae, to higher class, bryo, pterido, gymno, ngo. In all class of plants alkaloid is found, and in plants in animal it is also found in musk deer, it is also found in frog, it is also found in castor fiber. Okay, already written here. Okay, next most important is microbes. Alkaloids also found in microbes, so you can give this as number 1. Sorry, these are animals, number 2. Before that, algae, bryopterido are number 1, and now in third position you will find microbes. In Phycyanin, Pseudomonas species. So in Pseudomonas species, Phycyanin is also found, and Phycyanin is a type of alkaloids. Okay. Next, nomenclature. Next we are going towards nomenclature. Nomenclature is actually not so important, but it's okay. You can write it. Let's go to the nomenclature. So first of all, since these are alkaloids and they are all containing nitrogen in their structure, already I have mentioned earlier that they are alkaloids. They are alkaloids having nitrogen in their structure. And number two, they are derived from amino acid. So their name should be end with INE. Their name should be end with INE. Okay. Based upon their family, genus, species, and identification. The naming should be done based on their family, genus, species. Family, genus, species. When the name will end, it should be end with INE. It's important. Now we will proceed towards the extraction, general extraction procedure, which is very important. In the alkaloid part, all the alkaloid, the first important point is that chemical test for detection of alkaloid, and the second important point is general extraction part. So let's go to general extraction part. So general extraction of alkaloids. Okay. In this, the plant material is mixed with carbon tetrachloride. Plant material. Plant material plus CHCl3. CHCl3 means chloroform. CHCl3 is chloroform and CCl4 is carbon tetrachloride. So plant material is mixed with chloroform and it will give chloroform extract. Chloroform extract. This chloroform extract contains alkaloid. Okay, and in presence of lead acetate, it contains alkaloid. Now, in presence of lead acetate, lead acetate. In presence of lead acetate, in presence of lead acetate, it will give tannins. Tannins. Okay. Now this tannin is treated with H2S to remove the excess lead acetate. Why it is given? To remove excess lead acetate. To remove excess lead acetate, and after that it will be extracted. So this extract is again treated with dilute hydrochloric acid. Dilute hydrochloric acid, which is from alkaloidal salt. Alkaloidal salt, and then it converts into two different parts. One will be aqueous layer on the top position and chloroform layer will be on the bottom position. So you will see a structure like this funnel. Okay, let me draw it properly. In this panel you will find two different parts. One is aqueous layer and bottom part is, this is aqueous layer, whereas the bottom part is chloroform layer. This part is chloroform layer. Okay, take the aqueous layer which is containing alkyl salt. Take that aqueous layer, that part, top part, aqueous layer which contains salt, and extract from the salt with HCl. And now extract this from the salt with HCl. Okay, this is this aqueous layer. So extract from salt with HCl. Okay, then alkaloid will be found as precipitate. Okay, then alkaloid will found as precipitate. So this is most important. In this, the most important point which you have to remember is this one. Top position is aqueous layer and the bottom position is chloroform. Bottom one is chloroform layer. You have to remember that bottom part is chloroform layer and top position is aqueous layer, and we have to take that aqueous layer and we have to extract with HCl. Okay, then we will find the alkaloid. Okay, now what are the short trick? Now we are proceeding towards the main classes of alkaloids. So what are the main alkaloids classes? In this, from here you have to write anyhow, you have to write everything, you have to note that down. Okay, so shortcut for alkaloid is IIT question paper, IAS question paper. You write there IIT question paper, IAS question paper. Okay, so IIT question paper means indole. First one IIT question paper means indole alkaloid. Indole alkaloid. Next, second I means imidazoline alkaloid, or it is also called imidazole alkaloid. Indole alkaloid or imidazole alkaloid. Third T is tropane alkaloid. Tropane alkaloid. Next, four question paper. Q is quinoline alkaloid and P is purine alkaloid. Q is quinoline alkaloid. Quinoline alkaloid and P is purine alkaloid. So first IIT question paper is indole alkaloid, imidazole alkaloid, tropane alkaloid, quinoline alkaloid, and purine alkaloid. Indole alkaloid, imidazole alkaloid, tropane alkaloid, quinoline alkaloid, and purine alkaloid. Next IAS question paper. Now IAS question paper. So IAS question paper means isoquinoline alkaloid, quinoline alkaloid. Next amino alkaloid, isoquinoline alkaloid, amino alkaloid, IAS steroidal alkaloid, Then question paper, quinazoline alkaloid, and then pyridine alkaloid. Okay. So what are they? IAS question paper and IIT question paper. IIT question paper is indole alkaloid, imidazoline alkaloid, tropane alkaloid, quinoline alkaloid, purine alkaloid. Again, IAS question paper is isoquinoline alkaloid, amino alkaloid, steroidal alkaloid. Isoquinoline alkaloid, amino alkaloid, and steroidal alkaloid. Then quinazoline alkaloid and pyridine alkaloid. Quinazoline alkaloid and pyridine alkaloid. You have to remember that. Okay. Okay. So now we are going to learn about the different alkaloids which are found in these classes. So first one is indole alkaloid. Again, in indole alkaloid, what we will find? In indole alkaloid, we will find Parveen Sultana. Parveen Sultana is the singer, na? So Parveen Sultana. Parveen Sultana. She is the singer, na? Indian singer. So P means physostigma. Physostigma. E means ergot or ergotamine. Physostigma, ergot, Rauwolfia. Vinca, N is Nux vomica. N is Nux vomica. So physostigma, ergot, Rauwolfia, Vinca, and Nux vomica. These are example of indole alkaloids. Okay. Next is imidazoline alkaloids. Imidazole alkaloid, only one alkaloid is present, that is called single plant imidazole alkaloid, and the example is pilocarpus. Next, imidazole alkaloid. Imidazole alkaloid, only one is there. That is pilocarpus. Pilocarpus. Okay. Next, tropane alkaloid. IIT. Next, tropane alkaloid. Example of tropane alkaloid is very easy. It is called SBH DDC. Tropane alkaloid contains SBH DDC. What is SBH DDC? SBH DDC. So S for stramonium. Stramonium. B for belladonna. Stramonium belladonna. D for SBH. H for hyoscyamus. Hyoscyamus. D for datura. Datura. Next, D for duboisia. Duboisia. And next, C for coca. C for coca. So these are the example of tropane alkaloids. These are the example of tropane alkaloids. Okay. Next, quinoline alkaloids. So quinoline alkaloids is also very easy. Quinoline alkaloids contains only CC. Quinoline alkaloid contains only CC. quinoline alkaloids. These quinoline alkaloids contains only CC. What does CC means? C means cinchona and camphotheca. So first C is cinchona and second C is camphotheca. Camphotheca. Cinchona, camphotheca. Next, purine alkaloids. Purine alkaloids contains all types of what normally what people do after eating puri. They are you taking tea and coffee and all these things now. So actually purine alkaloids, P-U-R-I-N-E, purine alkaloids, it causes urination. Okay. So example are coffee, tea, cola, coffee, tea and cola. Next is isoquinoline alkaloid. Isoquinoline alkaloid. Isoquinoline alkaloid contains inorganic chemistry. Inorganic chemistry means IOC. So IOC ipecac, opium and curare. Ipecac, opium and curare. Next, steroidal alkaloids. Next is steroidal alkaloids. Steroidal alkaloids mean uh, steroidal alkaloids. So, for example, steroids are mainly taken by athletes and players. So, what happened is, you know, Ashwin, Indian player, Ashwin and Virat, both of them has taken steroid and they sat on the chair. So, in chair is called kurchi in Hindi. So, you can write Ashwin, that is Ashwagandha, Virat, that is Veratram, and Kurchi. So after taking steroid, Virat and Ashwin are sitting on the chair. So Ashwin, Ashwagandha, Virat, Veratram, and chair Kurchi. Next is quinazoline alkaloids. So quinazoline alkaloid only one is there, that is Vasaka. Next is quinazoline. Quinazoline alkaloids. Only one quinazoline alkaloid is Vasaka. Vasaka is the one and only quinazoline alkaloid. Next is pyridine piperidine alkaloids. Pyridine piperidine alkaloids. So what are pyridine piperidine alkaloids? Tobacco, lobelia and areca. Pyridine piperidine alkaloids. And example are tobacco, lobelia and areca. Tobacco, lobelia and areca. Okay, tobacco, lobelia and areca. Okay, so in next lecture we will start from indole alkaloids and we will learn each and every classes thoroughly with full information. Okay, so classification of alkaloids completed here. Classification of alkaloids completed. Classification of alkaloids. Thank you so much.